this year in Cloud SQL, we've really focused on 3 large areas. Overall performance and scale, make all of our databases faster, make them scale more easily, make as much of it as one touch as possible. Overall reliability and availability, because if your database isn't available, if it isn't reliable, what good is it? And then really full integration, trying to integrate it more deeply within GCP itself, and then also with the things out in the ecosystems of MySQL and Postgres that you care about. And again, things like SQL Server now as well. And we're proud of every single thing we've done this year, but I think a few that really warrant discussion are things like Postgres going GA, 9.6 is GA, and again, 11 is in beta. Our private IP work, and then our regional expansion, which we'll talk a little bit about as well. So lots and lots of stuff this year, lots and lots of stuff, lots of new regions. One of the things people may have missed is many, many more flags. We have for a long time had a pretty restrictive policy on what flags we allowed administrators to set for their database instances. And ultimately, we've kind of decided that in many cases, you know best, or you know what it is you're trying to do. And so if there was a flag in MySQL or Postgres you were looking for and you couldn't find it, check again. Both in our documentation and in our console UI, you'll find most of the flags that you're looking for Postgres and MySQL are now there. We've upgraded our proxy. We've added PostGIS support for JSON C. MySQL External Master has been a really great way for organizations to start to migrate their MySQL workloads into a managed system with Cloud SQL. Rotating SSL certificates, a real interesting move on the security side. And then connections from Cloud Functions, which I think over time is going to grow into a richer kind of external link trigger system as well. So again, highlight Postgres GA. We're seeing really, really great adoption in the Postgres side of the offering. I think those of you who know about the growth of Postgres over the last several years in the community understand that for certain enterprise functions, it really is becoming the open source database of choice. It's part of the reason we're going to have Simon join us to talk through some of the things we want to know as we move into 11. But with Postgres going GA, that means we now have SLA coverage, and it's going to be a major focus for us in the year to come as well. High availability, again, if your database isn't there, it's not really worth it. And so high availability has been a big focus for us on both the Postgres and MySQL sides of the house. And it's worth breaking these out a little bit because we're doing them a little bit differently. Now, on the MySQL side of the house, you can add high availability with just a single click. And what you're getting is bin log replications. You're getting semi-synchronous replication, and we're monitoring replication lag as our failover signal. Now, that means that there's no app-level difference for highly available stuff. It's the same as a single interface. But you do have the option of using that secondary replica as a little bit of a read replica as well. But you're dealing with the notion of replication lag as well. We're doing things a little bit differently on the Postgres side. Button. And this is actually going to be the strategy more broadly going forward for our high availability for SQL Server, for Postgres, and maybe we'll eventually bring it back to the MySQL world as well, which is actually to build on replicated persistent disks. Now, this is a truly synchronous replication, and so we're actually replicating the block device underneath the instance. And to be honest, this is a thing we're really only able to do because of Google's overall network capacity. It's very, very demanding to replicate a whole block device synchronously. Now, what this means, though, is that there's no replication lag, and it changes our failover metric a little bit. So in this case, if we get 60 seconds with no heartbeat, we know we need to failover. Now, you can't use that instance as a read replica, but you can set up regular read replicas to use otherwise. And you can continue to serve data from those from a healthy zone, even if that primary has gone down and we're in the process of failing over. And then private IP, I think, is actually a big deal for the security contrast and for those who are latency sensitive as well. Private IP is now available throughout the Cloud SQL line. And this is going to allow you to peer your VPC with the Google VPC in which our instance lives. Now, what does that mean for you? Well, that means lower latency for one. It also means that all traffic is encrypted. You can apply TLS to that as well if you want to, but it's going to be encrypted and never exposed to the public internet. And that is going to be a major driver for certain organizations that are network security sensitive. Wrong green button. And then regional expansion. I think this has been a highlight for GCP the last 3 years running now, is just how rapidly we're trying to expand across the globe. And we're now in 58 zones. I'm not sure exactly how many regions that is. It's many regions, each with at least 3 zones. And this is really giving you the opportunity to locate your databases closest to where you need to run your application, closest to where you need to do business. And again, this allows us the ability to have our replication exist in any one of the regions with, again, good failure domains across the zones. And now, let's get on to the next part of our discussion where we're going to dig more into the meat of some of the offerings themselves. We're going to talk about Postgres SQL 11 and a lot of things you should know. If you've only been running 9.6 or maybe running 10, there are a lot of improvements in 11 that are really interesting to talk about. And we're really, really lucky to have Simon Riggs with us. Simon, if you want to come up. Simon is the founder and CEO of Second Quadrant. Second Quadrant provides a wide variety of Postgres services in over, what, 20 countries? Is that right? And collectively, they have over 200 personal years of Postgres experience. Now, importantly, Simon is not just the CEO of Second Quadrant. He's also an active developer and committer on Postgres. And he's helped bring things like PITR to the community and partitioning and replication. So we're going to get the opportunity not only to see Postgres work in the field and talk about that, but also then sort of the committer's perspective on where the database is going. So please welcome Simon. Simon, thank you for coming.
Hi, no problem.
This is going to be a little awkward, so. Yeah, don't worry. All right, so let's start to talk first about parallelism, because I think one of the things I notice in 11 is there's been a lot of enhancements to parallelism. We see it in parallel query, we see it in parallel index build. So one thing I wonder about is, given that scan types and join types are now increasingly parallel, what are some things that users should know when they think about how parallelism is going to apply in their database?
Okay. Well, I think in 9.6 we introduced the basics of parallelism, but we didn't really roll that out to everything that could be parallelized. Whereas by the time we get to Postgres 11, the journey is almost done. If you look at what we've done in Postgres 12 release cycle, it's mostly bug fixing, and I'm actually very happy that we got the main join types done in Postgres 10 and 11. So, for example, initially we did hash joins, but they didn't use a single hash table. They had a separate hash table per, which was very wasteful. So, so really we're at the stage of hitting the secondary and tertiary issues with parallelism. So it's almost done, really. Very happy with it.
And so if users haven't really thought about how parallelism, how to take advantage of parallel query, are there things that they should think about in terms of setting up their schema, the way they think about table architecture, that will help increase their ability to leverage parallelism?
Yes, I mean, it's possible to get large parallel databases that exist out there with different databases, but with Postgres, what we focused on is small parallelism, so intranode parallelism. So we're looking for queries that can be somewhere between 2 and 4 times faster using this intranode parallelism. So really, a lot of important areas occur in applications where we've got certain queries that are a bit slower than they should be, but they're not running for necessarily hours. They could be like things that run for, say, a minute. And if we can get that down to 10 seconds or 2 seconds, then it's goal achieved. So, we're not really talking about the same world-encompassing parallelism that you get from some other products, but making simple changes to the response time of real-world queries.
Yeah, that seems that we would look to see that maybe in operational workloads that are dependent on real low latency or operational reporting, things like that?
Yes. I think what we're seeing with Postgres is that the old idea of an OLTP system where all the transactions are short isn't really what we see now. There's a whole mixed workload where you get OLTP, but also complex analytical queries happening immediately. For example, asking the question, where's your nearest coffee shop, or what's the best hotel for this particular customer to stay in? They need to be quick, but they're not short in terms of the analytical power required to answer them. And those are the things that we're targeting now.
Yeah, I suppose as the modern OLTP database becomes more analytically oriented, right, this actually matters. This notion of going from a minute to 10 seconds can be huge. So another thing that's interesting is parallelism in index builds, and I know people in the MySQL world would be familiar with things like parallel apply.
Yes.
Can you say a little bit about how parallelism for background work is evolving in Postgres?
So in terms of things, maintenance functions, I mean, we've got parallel vacuum, we've got parallel index build, which are the main ones really. We have moved away from the idea of trying to do maintenance on indexes, so just rebuilding the index is a practical task. And because we can do that concurrently, it's fairly simple to build a new index rather than try to maintain the other one. There aren't a whole load of other operations that you'd need to do in the background, but one thing we have done is parallelize create table as select, which is quite important for building summary tables and such like, which is an important application technique. So that's really one of the key things, I think, was the CTAS.
Yeah, CTAS improvement is actually really huge. I mean, you're talking about any kind of summary, either pre-offload to a warehouse or for operational reporting, like that can have a huge impact. So let's talk a little bit about partitioning, because I look at 11 and I think this is the partitioning release in a lot of ways. And you were very early in partitioning, but one of the things that people may not know about 11 versus previous versions is that we're no longer strictly in sort of table inheritance mode. We've got table attribute partitioning, it's native. But if you're coming from Postgres and you've thought about, oh, well, you know, I read Stack Overflow and I saw these inherited tables, it's different now. And so what should implementers think about, either if as they're moving from 9.6 upwards or 10 upwards, or if they're designing a schema from scratch and trying to think about how do I take the best advantage of the variety of partitioning options?
So yeah, I mean, I was originally involved in the work on partitioning back 10 years ago, and frankly, if I don't, not to diss myself, but the work that we did there was crude, and it led to some shortcomings really with the types of application that we could support. So what we've done now is completely redesign that, implement it from scratch the way it should be done, and as a result we're able to support things like unique indexes on partition tables and foreign keys, obviously very key for applications. And it's really made a big difference to the way that people are able to use this now. So partitioning isn't even done yet really in 11. We've still got a lot of good performance features coming in 12 and in 13. So partitioning is a really big application area for Postgres and maybe other databases as well. But we see those requirements coming very strongly from a whole range of users, because there's just so much data these days that people want to log, and partitioning really makes that effective.
So I guess just to poke on that a little bit, given the wide variety of things that are now present in partitioning, do you think that opens the door for organizations or users who are looking to move off of other RDBMS that have had maybe expensive partitioning packages or something like that? I mean, do you think that the level of functionality is enough that like there's a whole new wave of workloads that can come to Postgres with 11's partitioning?
Yeah, so the style of feature development with Postgres is, because we're releasing features annually, we will release a feature and then add things to it over the next couple of years. So it's not, maybe 5 or 10 years ago, you'd wait 5 years for the next release and then it would all come in one rush, except there would still be stuff broken, right? And then you'd wait another 5 years for it to be fixed. So the Postgres way is to release stuff a lot earlier. What we have with the initial partitioning is select queries will be fully optimized. Inserts are optimized into it. It's not really until Postgres 11 that updates and deletes are beginning to be optimized, and we've done more work on that in 12 as well. So the range of workloads is evolving. So if you want to do insert only, sort of append only workloads, they work just fine in Postgres 11, but we'll be moving on to a whole range of other applications. Your slides there mention partition-wise joins and partition movement. those two features are particularly relevant for sharding style applications built using partitioning, whether the partitions actually exist on separate nodes. And that's really a direction that we're moving in for the next couple of releases, is that sharding concept. So not too long away from having a fully sharded database running on Postgres. So.
That's great. I guess you make an interesting point there around the Postgres release cadence, and I think for people who are thinking about planning potential migrations to Postgres, if partitioning is a strong requirement, this notion that, well, we can begin to plan our migration now as the features are set but improving, it maybe can actually reduce some of the risk profile of that kind of a migration.
Yes, definitely. I think what some people say is that they won't move to a release until it's been out for 6 months. Well, obviously, with Postgres coming out annually, you don't really have to wait as long as you did before. Quite frankly, the profile of testing has changed dramatically in software generally, and most specifically in Postgres. So whereas we used to rely on the kind of many eyeballs effect for people reporting queries, the extent of our test automation is now, I mean, I can't put a number on it, but it's much different to how it was. And so you have a lot of trust in the .0 release now, whereas before people said, well, maybe wait for the .1, .2. But it's usable really from the word go. So every September now, you should be thinking about upgrading your Postgres.
That's really interesting. So let's talk about another one of these, hey, maybe I have an expensive database at home and I'm interested in getting away from it. Another huge thing in 11 is stored procedures. And I think the community's had functions for a long time, but procedures, they play a real role in ensuring conformance, in reducing network traffic, a bunch of things. And you guys at Sync at Quadrant actually did a lot of work on the stored procedures as well. Can you talk a little bit about what you think they mean for the community? And I guess same question, if I'm thinking about coming from a database that is on premises or is maybe something I'm trying to get off of, but stored procedures have been a blocker, how is the door open now in a way that it wasn't?
Okay. So there's a small difference between procedures and functions. I mean, functions are essentially, or procedures are, they're very similar in many ways, but the key difference that we've introduced with stored procedures is the ability to run transactions inside the procedure, and that is a really pivotal difference. It's important for migration from other databases, but it allows you to do a whole range of things you really weren't able to do before. So batch-style query processing, and we're also sort of moving towards autonomous transactions within procedures, perhaps in the next release. But the style of programming changes completely, because when you had a function that would only exist within one transaction, you're now having a procedure that can exist, perhaps generating thousands of transactions as it executes. Completely different style of programming, and it really moves a lot of the business logic through to the server now. Because whereas before you had to ask for one transaction and then another transaction, the procedure can just do it all. It's like come back when you're finished now. And that means that the network traffic that you're reducing between the application and the database is really considerable now. So we get the full benefit of offloading things to the database. Obviously, not every single piece of your application should live in the database, okay? I think some people tried to persuade people that was a good idea, and it's not, okay? But there are some things that make sense to be close to the data, okay? And for those, it's ideal.
Yeah, it's interesting that you mentioned the notion of having multiple transactions within the procedure. I recall, working in financial services and other places, that the notion of straight-through processing can be a real impediment for certain organizations that need to make sure that when this row is touched, all of these other rows are updated. And so this really opens the door to that. Do you find that you're seeing growth in the sort of regulated industries on Postgres?
Absolutely. Yeah, I mean, probably half of our customer base is financial services now, very widely used across financial industries. And when I say that, I think some people think, oh, right, so somewhere in the back room, he's got like one Postgres database and he's claiming that as usage, right? No, I'm talking about card processing is now frontline done on Postgres. So if you buy something on various cloud providers, you will find that that goes through Postgres databases. And there's literally hundreds of billions of dollars annually processed directly on Postgres databases, supported by us, by the way.
Well, there's something interesting within that too when you start to talk about global organizations. And I know one of the areas that Second Quadrant's done a lot of work beyond things like stored procedures is also in logical replication, things like BDR. Could you talk for a moment about how you're seeing sort of cross-regional replication emerging in the Postgres community and the kinds of use cases you're seeing for it, be it disaster recovery or split transaction processing, the sorts of things that really show up there?
Certainly. Yeah, I think there's various ways of doing high availability within a single region, but when you go cross-region, things become a lot more complex, and some of the storage replication techniques that are possible become much more problematic. So Postgres has invested a lot of time, and Second Quadrant as well, in what we call logical replication. And the purpose of that is to filter out all of the physical replication stuff so that we're just down to the basic data. So that reduces bandwidth, but it also allows you to do things like upgrade between release, and it certainly makes cross-region replication significantly easier. With something like BDR, we actually have global geo-sharding, where you can actually have pools of data in different continents and yet all working together. So again, important technologies, especially in regulated industries.
And just in case folks don't know what BDR is, bidirectional replication. That's, I think you and I know enough. There's like, oh, well, of course, this. So let's talk about, we talked a little bit about the importance of analytics within the Postgres world. And I mean, in a lot of ways, Postgres is really well positioned to be both your analytical workhorse and for operational things and your OLTP database. The other thing that really stood out to me in 11 is the changes to Analytical SQL. And I think in many ways, I look at Postgres' SQL syntax as being, in a lot of cases, at the very edge of how we think about the SQL language. So for folks who haven't looked at it, Postgres 11 gives us frame exclusions, which I think are really, really powerful, ways to actually remove things from the windowing frame. And then also group frame units, which is I don't think any other database today does group frame windowing. Can you talk a little bit about each of these and like what it means to the analytical workload?
Sure. So I think what a lot of people don't realize with SQL is that it's had window functions in it for some time. Now, what a window function is it allows you to look at data in an ordered manner. And this is especially important for time series, where if you're thinking about your data as a graph where the points change over time, then if you can write queries that analyze that data so that you have a sliding frame of data. So, for example, if you look at the current row of data, you can look at the last 5 preceding rows and write something like a moving average, which is obviously a very important analytical calculation. So this has actually been in the SQL standard for many years, and Postgres has had support in that for coming up for 10 years now. But in the latest release, we've got these fine-grained extensions, really, that put the finishing touches to Postgres' support. And the ones that you mentioned there really are just important in really just getting the last few dregs of information out of that style of query. And what's really surprising, though, is we're finishing the implementation of these features, and yet many people have never even heard of them. Okay, and so sometimes when we talk about SQL as a kind of boring language that existed from 30 years ago, people are not really moving with the fact that it's actually evolved very considerably over time.
Yeah, modern SQL is really something. I guess, yeah, to think a little bit about that to the finer grains, at a frame exclusion, I might have my moving average, but I might want to say, well, give me the last 5 values, but remove the duplicates, right? And that could actually have a really material change on the average I'm computing. And again, that sliding window doesn't necessarily have to be rows proceeding anymore, right? It can now be groups. And so if I'm actually talking about group by averages, that can be really interesting. All right, so let's talk a little bit about data types. I think Postgres already has got a really rich support for data types, whether it be array types, structured types, domains. But I think one area that's interesting is semi-structured data, because JSON and JSONB have become, I think, interesting additions to Postgres in general, and in particular, I think at 11 we got full text indexing. Or it might have been 10, I'm not 100% certain. So are you seeing more use of semi-structured data in the Postgres world now that these features are available?
Very much so. I think people have bought into the concepts of semi-structured data from a lot of other databases, but they want to use those concepts within a normal database structure. So they want to be able to mix the concepts together. There are, relational works, but up to a point. And then once you go sort of past that point where you hit the complexity wall, semi-structured data is really useful. So it's great to be able to just have a column where you have sort of data blobs in. And JSON and JSONB is just excellent for that. So we have lots of people using it. So it's not something that's in the back rooms. It's really one of our key features these days. The JSONB data type compresses the data, so we store it compressed, but in a way that you can still search on the compressed data, which obviously is a very important feature. So the full text support that we've released in Postgres 11 is actually enabling two things that were in Postgres previously. Obviously the JSON data type, but the full text support allowed us to build indexes on data, but in a very complex way. So we could have things like a Russian grammar for words in the JSON blobs. And you've got things like a stemmer that will take the front portion of the word. So instead of a word that ends with ing, we can just take off the ing, and it'll be the main word that we're talking about now, and we can just index that instead. So that the full support of full text is now available on top of JSONB data. So a very important combination.
That's really interesting. I think one of the things that kind of highlights between thinking about the analytic functions, thinking about semi-structured data types, and being able to actually effectively do complex processing on them, is that I often think of Postgres as, it's an OLTP system mostly, but the reality of it is it's really a multi-model database in a lot of ways. Like if you need to do things that are somewhat key value oriented, if you need to do things that are more sort of Elasticsearch full text indexing, like these are all capabilities available to you, and if you need to bring them all together in one database, Postgres is really about the best you can do in the open source world.
Very much so. I mean, I think that's really been the power of Postgres, is to, while many vendors have been highlighting, I've got this great database as long as you accept this long list of restrictions, okay? And then, and then there's another database server that has a different long list of restrictions, and trying to build an application that integrates different servers together works at the prototype stage, and then someone says, how will I back it up, right? And simple things like that become really complex. And what Postgres has done is said, really, there aren't any restrictions. You can have all manner of data types with all manner of index types, and we support OLTP queries, longer analytical queries. We support graph queries, for example, not very well known, window queries. And this really gives you a breadth to Postgres that means that when you're building an application, you can be pretty certain that you will be able to build it on Postgres. Whereas some of the other platforms, you have to look carefully at the list of restrictions before you decide whether to use it or not. And if your restrictions change after your initial build, you're in problems. And that's really the strength of Postgres, has been the confidence that it gives application builders, because, as I said, you can be certain that Postgres will run it.
Yeah, it's actually a great platform to avoid pre-optimization, right? You can optimize when you need to, but if you're not quite sure, Postgres will probably at least get you most of the way. All right, so it's a new release, and you can't have a new release of a database without somebody wanting to talk about speeds and feeds. So this is not any kind of an official benchmark. This is just, I spent a little bit of time one afternoon looking at Postgres 9.6 on Cloud SQL and Postgres 11 on Cloud SQL. I was just looking at sort of effectively TPMC. And I think I see some interesting things, right? The theoretical throughput is up. Overall, we see improved behaviors. But I know there's been a bunch of work that's gone into the planner, into stats collection, things like that. Anything you want to say broadly about overall performance in 11, or things that users should be aware of, they should be taking advantage of, that maybe they didn't read deeply enough in the liner notes to know about?
Well, thank you for asking that question, because that's really the things I like to highlight, is those things that are kind of buried in the notes. But really, I'd like to celebrate what you see on the screen there, because if you look, I mean, the numbers there are extraordinary. We've gone from 8,000 TPM to 12,500, which is more than a 50% gain in performance in OLTP. And that's really just one workload that has been optimized, because there's a whole range of other workloads that we support. So, I mean, that in itself is, we could talk for 5 minutes really about that. But really, to answer your wider question, what we've been doing is not just expanding the execution speed of queries with things like aggregation improvements or parallel query, but we've also looked at the statistical information that we keep within the database. So we now support something called the create statistics command. And what that allows you to do is tell the database that multiple columns are actually linked. For example, there's a common example of in the US, you have area code and state. Now, we all know that area code and state are related, but the optimizer doesn't. And it's only when you tell it that these two columns are actually related, and the area code for Los Angeles is not the area, is not possible to have a customer with an area code in Los Angeles when they live in New Jersey. It just doesn't happen, okay? And so the optimizer can use those types of information to really change the selectivity estimates. And when you get the selectivity estimates right, you get the right query plan. And most of the reason for poor performing queries is actually because of the optimizer's ability to understand what's happening. So I don't want to denigrate the massive work done on parallel query at all, but we've done an equal amount of work on the optimizer, on statistics. So, for example, in Postgres 10, we introduced for the first time foreign keys into planning. So previously, foreign keys were just a constraint, right? Whereas now, the foreign keys are actually taken into account in the planning. And that means you get much better plans and faster queries as a result. So those are not really admin tasks. There's some pretty cool admin things out there as well. But really, performance across across all of the different workloads has improved really quite considerably.
That's awesome. And yeah, I think that the notion of understanding that we can now actually help improve those plans in ways we couldn't before. Like, yeah, any of us who've ever run a benchmark know that if you don't get a good plan, like it's just like life. It's just like life. All right. Well, Simon, thank you so much for joining us. Everybody, give it up for Simon Riggs, CEO of Second Quadrant. Wow, there's a lot of stuff in PG11 you guys have got to go check out. It's really, really cool. So let's talk just briefly about the year ahead, and then I'll hand it back over to Ori, who's going to give us another taste of SQL Server in case you didn't see it on the keynote stage. So in 2019, there's a lot of stuff we're interested in. New database versions, new databases, for example. Some security features we think are really important. Customer managed encryption keys. This is a broad requirement for all of Google Cloud, and you're going to see it in Cloud SQL very, very soon. Richer auditing. Simon and I talked a little bit about regulated industry, financial services, healthcare. We really want to improve the level of auditability in Cloud SQL so that we're, yet again, further ready for these kinds of workloads. We're also going to spend a lot of time this year focusing on manageability. If you've run Cloud SQL and you wonder about maintenance events, we know. We're working on both deferrals and event controls, and these are things we're really going to focus on making at least first class in the coming year. Point-in-time recovery for all of our databases is a huge priority. We already have it in the MySQL world. You'll see it in Postgres, and obviously you'll see it in SQL servers, and that's something you expect. Our overall manageability UI, we're going to invest a lot of time into and try and improve that. And we're also going to start to begin a journey towards greater federation with the rest of the GCP platform. One of the areas that we expect to invest in this year is federation from BigQuery, which is to say if you have a warehouse stored in Google BigQuery, you'll be able to reach in to your Postgres database and query analytical data or query operational data that may live there. We're also very interested in potentially having Postgres reach out to the rest of GCP. We think that's a really interesting area that we're going to investigate going forward. And with that, I'm going to go ahead and turn it over to Ori, who's going to tell us about SQL Server.
Great. Thank you very much. Hi, everyone. So I am here today to talk to you about a product I'm sure have never heard of, SQL Server. We're really excited to announce that we've expanded our portfolio for Cloud SQL, and now we will be offering Managed SQL Server. Currently, we're launching our closed alpha. Beta will come towards the end of this year, and that will be open to all customers. Now, a lot of what Dan was talking about and why it's so important to be part of the Cloud SQL family is really that SQL Server is going to take advantage of a lot of the platform goodness that we're bringing already to MySQL and Postgres over the coming year and leverage that same, the same set of features. So when you talk about, I get the question all the time, what regions is SQL Server going to be available in? The answer is everywhere that Cloud SQL is available, that's where SQL Server is available. And same goes for what our automated backup story is going to be, point-in-time recovery is coming, patching story, all that. We are going to have kind of this unified experience that you can come to expect as a standard from GCP for our managed services, and SQL Server will be no exception. And so that's going to add, hopefully a lot of value, reduce a lot of the overhead in terms of managing SQL Server and how it interacts with your apps. Additionally, I want to talk a little bit about compatibility. So, SQL Server, in most organizations that we've run through with a lot of the customers, they already have kind of their workflows baked in. They have their favorite tools, they have their third-party, analytics services or whatever else that are kind of running on top of SQL Server. One of our top goals is actually to make sure that we are able to preserve that level of compatibility. So we're not going to introduce something where you have to break your normal flow, retrain a bunch of your folks. We expect you to be able to continue doing business as usual, just with a managed service in the background to reduce, again, a lot of that maintenance and overhead. Just some quick bullets. So, SQL Server 2017 is going to be the version that we're going out with. As I said, there is kind of this versioning strategy across all of our managed database services that we will continue to keep up to date with, of course, the minor revisions. And as the major versions come out too, we'll evaluate them and make them available as well. We're starting out with our alpha standard edition, but we will, at the time of beta and GA, have all editions available to our customers. The VM shapes that are underlying this are going to be the same as the rest of Cloud SQL. Again, there's that kind of standardization across the Cloud SQL family. And so everything that you see that customized, I think already in Postgres, there's custom VM shapes. That's actually the standard that we're going to adopt. The only limitation, of course, is going to be the different editions of SQL Server have kind of baked in limits on what they can utilize as far as memory and cores and things like that. And then, finally, again, Dan touched on this a little bit, with the comment about federation with BigQuery, but I think it bears repeating that integration with Stackdriver, integration with all the other available tools and services that kind of proliferate around the GCP ecosystem is going to be one of the biggest value adds that we have, and SQL Server is going to benefit a lot from that. And so if you are already kind of a customer for any of our other services, using compute, using something else, this should be an easy add-on to if you have a stubborn workload that's remained on-prem or in a VM, even in GCE, that you want to kind of go to a managed model. That's something that will be available to you. I think the slides are available after the session, so there is a link if you are interested in alpha to show your interest, sign up. We have a set of customers selected now, but we'll be expanding the alpha as we get closer to beta, and we welcome any interested parties. We're happy to have you if there's space. And with that, everyone's favorite thing, a demo. So this is actually running on SQL Server 2008 R2. It's going end of life, obviously, in later on this year, in just a few short months, actually. Team that we start out with .back as the first supported, backup restore file type. Obviously, that's the native one for SQL Server. I know the team worked very hard to make sure that that is first out the gate. And then after that, we actually have an incredibly simple import flow, and it's very similar to what you've already seen for .SQL and .CSV imports, but I'm just going to go and select this .back file that I've uploaded previously. There we go. And I just name it to, let's call this skidb001. I'll click import. And while that is happening, I'll actually, this usually only takes a minute. I'll copy over the IP. I've got the configuration file over here. I'll paste it. And with any luck, it should still be up. Yep. All set. So now this web app is running on our managed service, and it was that simple. And that's actually our goal for our customers. So we want to make sure that if you have more complex apps, obviously it's going to be more than the stepwise process I just showed you. But we want to provide you with the tooling, not just the simple flows, but also through third-party relationships, through other tool sets that we'll make available. You, of course, heard about the Illuma acquisition that happened earlier this year, or just earlier this month. And we're really doubling down on making sure that the migration onto GCP, onto our managed services, is smooth and painless. One other thing I wanted to call out before we get to the Q&A is actually two things. One is a quick shout out to our managed AD service that is also launching right now. And for GCE as a whole, we kind of have an entire Windows ecosystem offering now, which it's a much more complete story than what was, of course, previously available. And so whether you're trying to run Windows Server on on GCE, whether you're looking to use our managed AD service and managed SQL Server, now you don't have to kind of bitwise or piecemeal move onto the platform. We can actually accommodate your entire ecosystem and your entire stack.